Hello friends, today we are going to discuss solution. Solution is very important chapter in 12th class chemistry. Many interview questions are asked from this chapter. Personally, when I go to give interview in Savita Oil Technologies, one of the best oil manufacturing company who manufacture engine oils, many questions asked from this chapter. And similarly, when I go to give an interview in Lupin, one of the big manufacturer of API, active pharmaceutical ingredient, so in that company also many interview questions asked from this chapter. And then I go to Ranbaxy, which is now known as Sun Pharmaceutical Limited. So many interviews questions asked from this chapter, that place also. So you know the importance of this chapter in your chemistry study. So let's study this chapter. A solution is homogeneous mixture of two or more chemically non-reacting substances whose composition can be varied within certain limits, expressing concentration of solution. First is percentage. The mass percentage of a component, that is weight by weight, is equal to mass of the component in the solution into 100 divided by total mass of the solution. Second is volume percentage of the component, that is volume by volume, is equal to volume of the component into 100 divided by total volume of the solution. Third one is mass by volume percentage of the component, that is weight by volume, is equal to mass of the component in the solution into 100 divided by total volume of the solution. So friends, do remember these three formulas, as if you do job in any solution related industry like pharmaceutical industry, paint industry, oil industry, API industry, there is the use of these formulas daily in daily life there, like in the preparation of disinfectant solution, in the preparation of the API, in the preparation of the pharmaceutical ingredients, in the preparation of the paint oil compositions. These formulas are used, so do remember these formulas. Next is strength. Strength of the solution is denoted in gram per liter or gram per decameter cube, is equal to mass of the solute in gram by volume of the solution in liter. Next is molarity. Number of moles of the solute divided by volume of the solution in liter. So M is equal to strength in gram per liter divided by molar mass of the solute. I repeat, M, that is molarity, is equal to strength in gram per liter divided by molar mass of the solute. Now mole fraction. Mole fraction is obtained by dividing the number of moles of the solute or solvent by the total number of moles of the solution. So mole fraction x1 is equal to n1 divided by n1 plus n2, and x2 is equal to n2 divided by n1 plus n2, where n1 is equal to number of moles of the solvent and n2 is equal to number of moles of the solute. So x1 plus x2 is equal to 1. Mole fraction, mass fraction. Mass of the given component per unit mass of the solution denoted by x. So XA is equal to WA divided by WA plus WB. XB is equal to WB divided by WA plus WB. WA is equal to mass of the solvent and WB is equal to mass of the solute. XA plus XB is equal to 1. Now we are going to discuss solution of solids in liquids. Solubility of a solid in a liquid. It is defined as the maximum amount of the solid, that is solute, in grams which can dissolve in 100 grams of liquid solvent to form the saturated solution at a particular temperature. Factors affecting the solubility of a solid in liquid. First, nature of the solute and the solvent. Like dissolves like, that is, the polar ionic compounds like NaCl dissolve in polar solvent like water. The non-polar covalent or organic compound dissolve in non-polar compounds like anthracene dissolve in benzene. Second, effect of temperature. The solubility increases with increase of temperature when the process of dissolution is endothermic. Endothermic. I repeat, the solubility increases with increase of temperature when the process of dissolution is endothermic. That is, solute plus solvent plus heat gives solution. Example: NaNO3, KNO3, NaCl, KCl. Second, the solubility decreases with increase in temperature when the process of dissolution is exothermic. That is, solute plus solvent gives solution plus heat. Example: sodium carbonate monohydrate Na2CO3.H2O. Third, those whose solubility does not increase or decrease continuously. Example: CaCl2 plus 6H2O dot 6H2O gives CaCl2 dot 4H2O gives CaCl2 dot 2H2O. Next one is solution of gases in liquid. Solubility of a gas in a liquid. The solubility of a gas in a particular liquid is the volume of the gas in centimeter cubes, also known as cm cube, that can dissolve in unit volume of the liquid to form the saturated solution at the temperature of the experimented under a pressure of 1 atmosphere. I repeat, solubility of a gas in a liquid. The solubility of a gas in a particular liquid is the volume of the gas in centimeter cubes that can dissolve in unit volume of the liquid to form the saturated solution at that temperature of the experimented under a pressure of 1 atmosphere. Now, factors affecting the solubility of a liquid in a gas. First, nature of a gas and solvent. Gases like hydrogen, oxygen, nitrogen, etc. dissolve in water only to a small extent, but gases like CO2, HCl, NH3 are highly soluble. The greater solubility of latter gases, they react with the solvent. The greater solubility of a gas in a solvent due to their chemical similarity. Means if there is a similarity between gas and the solvent, then there is the chances of higher solubility. Second one is nature of temperature. The solubility of gases decreases with increase in temperature. Effect of pressure. Henry's law. By increasing the pressure, solubility also increases. Now, Henry's law. The mass of a gas dissolved in the given volume of liquid at constant temperature is directly proportional to the pressure of a gas present in the equilibrium with the liquid. That is, M is directly proportional to P, and M is equal to KHP. Also, the partial pressure of gas in vapor phase P is proportional to the mole fraction of gas X in the solution.
So P is equal to KHX. Limitations of Henry's law. Henry's law is applicable only if the following conditions are satisfied. That is, pressure should be low and temperature should be high. Gas behaves as an ideal gas. The gas should not undergo compound formation with solvent or association or dissociation in the solvent. Vapor pressure of liquid solution. Vapor pressure of liquid solution is the pressure exerted by the vapors in equilibrium with the liquid or solution at a particular temperature. Raoult's law. It states that for a solution of volatile liquids, the partial vapor pressure of each component in the solution is directly proportional to its mole fraction. For component A, PA is directly proportional to XA. Also, PA is equal to P0A XA, where P0A is equal to vapor pressure of pure component A at the same temperature. For component B, PB is equal to P0B XB. By Dalton's law of partial pressure, P total is equal to PA plus PB. Also, P total is equal to P0A XA plus P0B XB, also equal to 1 minus XB P0A plus P0B XB, also equal to P0A minus P0A XB plus P0B XB. So P0A plus P0B minus P0A XB. If Ya and Yb represents the mole fraction of component A and B respectively in vapor phase, then Ya is equal to Pa divided by Pa plus Pb is equal to Pa by P total. This is equation first, and then Yb is equal to Pb divided by Pa plus Pb is equal to Pb by P total. This is equation second, and now from these two equations, first and second, we get Pa is equal to Ya into P total and Pb is equal to Yb into P total. In general, Pi is equal to Yi into P total. Now, Raoult's law for non-volatile liquids. Vapor pressure of each component is directly proportional to its mole fraction. So P1 is directly proportional to X1. So P1 is equal to P0 1A 1 X1. Also P1 by P0B P01 is equal to X1. Now, ideal solution. An ideal solution is that solution which obeys Raoult's law in all conditions of temperature and concentration. That is, delta V mixing is equal to 0 and delta H mixing is equal to 0. Also, forces of attraction between components are same as in pure state. So A minus A is equal to A minus B is equal to B minus B. Here minus means bond sign. So you can also read it as A dash A is equal to A dash B is equal to A dash B is equal to B dash B. Non-ideal solutions. This solution which do not obey the Raoult's law is known as non-ideal solution. So in this type of solution, delta V mixing does not equal to 0. Similarly, delta H mixing does not equal to 0. So the force of interaction between solvent and solute is different than in pure state. Now, positive deviation. In this positive deviation, A dash B interaction are weaker than A dash A or A B dash B interaction. That is, interaction between solute and solvent is weaker than solute and solvent interaction. This means in such solutions, the molecules of A or B, that is A dash B, will find it easier to escape than in pure state. Now, negative deviation. Intramolecular attraction forces between A-A and B-B are weaker than those between A-B. This decreases the escaping tendency of molecule for each component A-B, and consequently the vapor pressure decreases, resulting in negative deviation from the Rolle's law. Now friends, we are going to discuss colligative properties. Those properties of ideal solution which depends only on the number of molecules of the solute dissolved in the definite amount of solvent and do not depend upon nature of solute. The important colligative properties are relative lowering of vapor pressure, second osmotic pressure, third elevation in boiling point, third depression in freezing point, next relative lowering of vapor pressure. So relative lowering of vapor pressure from Rolle's law for solution of solids in liquids, P0 minus Ps divided by P0 is equal to N2 divided by N1 plus N2. Since X2 is equal to N2 divided by N1 plus N2, where P0 is equal to vapor pressure of pure solvent. So Ps is equal to vapor pressure of solution, N2 is equal to number of moles of solute, N1 is equal to number of moles of solvent. For dilute solution, N2 is much lesser than N1. Hence, neglecting N2 in the denominator, we have P0 minus Ps divided by P0 is equal to N2 divided by N1, also equal to W2 into M1 divided by M2 into W1, where W1 and W2 are the masses and M1 and M2 are masses of solvent and solute respectively. Osmotic pressure. Osmotic pressure is very important and it is also asked in many interviews, so do remember this. The process of the flow of the solvent molecule from solvent to solution through semi-permeable membrane is called osmosis. The flow of the solvent molecule can be stopped if some extra pressure is applied on the solution. This pressure that just stops the flow of the solvent molecule is called osmotic pressure of the solution. I repeat, the process of the flow of the solvent molecule from solvent to solution through semi-permeable membrane is called osmosis. This flow of solvent molecule can be stopped if some extra pressure is applied on the solution. This pressure that just stops the flow of the solvent molecule is called osmotic pressure of the solution. So, osmotic pressure of the solution is directly proportional to the molar concentration or molarity C of the solution and its temperature T. Mathematically, pi is directly proportional to C, pi is directly proportional to T, pi is directly proportional to C into T, or pi is equal to R into C into T, where R is the solution constant equal to the gas constant. So pi is equal to CRT. Hence pi is equal to N2 by V RT. This equation is called Van 't Hoff equation for dilute solution. Also pi V is equal to N2 RT. But N2 is equal to W2 by M2 is equal to weight in gram of solute dissolved in V liter divided by molecular mass of solute. So pi V is equal to W2 RT divided by M2 is equal to M2 is equal to W2 RT divided by pi b. Elevation in boiling point. It is found that the boiling point of the solution is always higher than that of pure solvent. The increase is called elevation of boiling point. Dear friends, if you find any type of difficulty during listening, do open the notes of this chapter from our website www.chemistrynotesinfo.com under 12th class section, and there you get the chapter solution. So open this chapter and read notes also, so you understand very well the equations with graphs, because I don't explain graphs, but there is also a graphs in the notes. So do open these notes on from our website www.chemistrynotesinfo.com. Let's continue. Elevation in boiling point. It is found that the boiling point of the solution is always higher than that of pure solvent. The increase is called elevation in boiling point. We know delta TB is equal to TB minus T0B, where T0B and TB is the temperature at which the vapor pressure of the solvent and the solution becomes equal to the atmospheric pressure, and delta TB is called elevation in boiling point. Also, delta TB is directly proportional to M, and delta TB is equal to KBM, where KB is the molal elevation constant or ebullioscopy constant, and M is the molality of the solution. Calculation of molecular mass of the solute. As molality is the number of moles of the solute dissolved per 100 gram of the solvent, as molality is the number of moles of the solute dissolved per 100 gram of the solvent. If W2 gram of solute of molecular mass M2 are dissolved in W1 gram of the solvent, then M is equal to W2 divided by M2 into 1000 divided by W1. So delta TB is equal to KB into W2 divided by M2 into 1000 divided by W1, or M2 is equal to 1000 into KB into W2 divided by delta TB into W1. Depression in freezing point.
It is observed that the freezing point of the solution is always lower than that of pure solvent, and decreases is called the depression in freezing point. Delta TF is equal to T0F minus TF, where T0F is equal to freezing point of pure solvent and TF is equal to freezing point of solution. Similarly, delta TF is equal to depression in freezing point. Also, delta TF is directly proportional to M. So, delta TF is equal to KFM, where KF is the molar depression constant or cryoscopic constant, and M is molality of the solution. Calculation of molecular mass of solute. Delta TF is equal to KF W2 divided by M2 into 1000 divided by W1, or M2 is equal to 1000 into KF into W2 divided by delta TF into W1. Vent off factor. It is defined as the ratio of the experimented value to the calculated property of the colligative property, known as Vent off factor. Dear friends, we completed solution chapter. You can also download PDF copy of this chapter from our Telegram channel. So search on Telegram @chemistry notes info and you get the channel Chemistry Notes Info, from where you can download PDF notes of this chapter and You can also read notes of this chapter from our website www.chemistrynotesinfo.com. You can find the link of our website and Telegram channel in the description of this podcast. Thank you to listening this podcast. This podcast is brought to you by Chemistry Notes Info learning platform.